Okay, you are live.
Thanks, David. Welcome everyone to the Hyperledger Meetup Bevel Workshop series. Um, so this is the third session of that we'll be doing, and in the previous sessions, particularly the first one, we did a deep dive on. Just a second, yeah, we did a deep dive on our latest release on Helm only deployment. We also spoke about our new Helm charts and also the code structure that allows us to now have cloud native vaults. In the second session, we continued talking about the Helm only deployment and demonstrated the newer Helm charts by deploying Fabric. Now, in today's session, we'll be using the same Helm only deployment using our new Helm charts and show you the production ready deployment of Hyperledger Besu. Before we jump into the demo, let me just quickly hand over to Sownak, who is one of our speakers today. Sownak, off to you for a quick introduction.
Hello, hi. Yeah, thanks, Suvajit. Hi, everyone. This is I'm Sownak Roy. I'm an I'm working with Accenture for past what 8 9 years now, but now in total I have around 18 years of experience in whole technology, engineering, and also architecture. Yeah, I've been the product owner of Hyperledger Bevel since its inception, and yeah, the main maintainer and the reviewer. Uh, yeah, and those are my details on LinkedIn and Twitter, X. Yeah, so that's all. Happy to be here, and hopefully, it will give you some insight into how you can use Bevel for Hyperledger Besu deployments.
Okay, thanks, Sownak. Uh, and myself, Suvajit Sarkar. I have total of 11 years of experience in technology management and software engineering. I currently work with Accenture. I'm one of the maintainers of Hyperledger Bevel. My past experiences were in Oracle and Sapient Global Markets. You can see my LinkedIn and Twitter handles here in the screen. And I guess, Shaunak, you can take this. Shaunak, you want to take this?
Yeah, sure. Sorry.
Okay.
Yeah, so this is like the summary slide which we do for every meetup. So this is the third and final one for at least for this, I guess, for this year. So yeah, Hyperledger Bevel. What is Hyperledger Bevel? It is an automation framework which is used to rapidly and consistently deploy production-ready DLT platforms onto Kubernetes clusters. So it is an Accenture developed and tested and also open source and open development project under now Hyperledger Foundation or Linux Foundation Decentralized Trust. Uh, but it allows the developers as well as operators to set up a secure and scalable blockchain solution, and you can use the same kind of approach to do your POC as well as put it to production. So because it is production ready and deploy, and it helps in reducing your development and deployment times from weeks to hours. Because you don't have to do you are already working on a production like environment from start itself, from your POC or dev environment itself, so you don't have to do a lot of changes when you are actually moving to a production network. Key features of from release one onwards is the Helm chart. So basically, it's more Hyperledger Bevel has become has moved on from Ansible and has become more like a Helm chart repository for all the platforms, and it simplifies all the complex deployments of the DLT platforms. The security best practices are already inside these Helm charts as well as if even if you're using Ansible. So because it uses Vault, it has support for to write your code to integrate with the cloud native key management systems as well. Scalability, I think that was already there. It is designed for expansion easily. You can just add additional organization and run the same command. It will work for most of the platforms. That's how it works. It adds to the scalability. Then we have the accelerated deployment. Oh, yeah, that is the main feature, right? You want to create the DLT environment quickly. And then, of course, developer flexibility with release 1.0 on 1.1 onwards, you have the option to deploy without HashiCorp Vault, as I said, which will use the default Kubernetes secret managers secrets, and also you can deploy without Flux. In which case you don't need a GitHub repository. Don't need to save the manifest files into a GitHub repository. So that's those are the features. The key features, of course, there are all the additional features as well, which is the basic ones.
Yep.
Next slide. Yeah, so from highlights of release 1.1, which we did in July, it is main highlights. We changed from Ansible to Helm only deployment. So which means that you do not need to have Ansible, which many people found it difficult, especially if they were working from a Windows machine. So you can just do Helm install or Helm upgrade commands to deploy the network. The only thing is that it is a bit manual because you have multiple Helm commands, especially if you are creating multiple organizations. But you still have that automation via Ansible. So if someone has like a 10 node network, of course, now no one is try asking you to run say 30 Helm install commands. So you still use the Ansible to provide that level of automation, or you can write your own, integrate with your own, even a shell script or any other Argo CD or anything else that is there. There is a proxy or no proxy deployment. I think this was already there, but it has become more evident now. So you can apply a proxy with a proxy or a no proxy. So yeah, generally no proxies is a single cluster environment, whereas proxy is for multi-cluster environments. And then you have Kubernetes secret as key storage. So we are not we've removed the dependency on Vault. So Vault is also there, and it is suggested for all production worthy deployments, but you have the for local smaller scale deployments, still have the option to use Kubernetes secret as the key instead of Vault, basically. So those are the three main changes that we did from release 1.1 onwards.
Thanks, Shanak. So I'll take over, reshare my screen, and we can start with the demo. So just give me a moment.
Any questions in that meantime? Okay, no.
Right. Is my VS Code visible?
Yes, we zoom in.
Yeah. Should be fine, right?
Yeah.
Okay, so for the demo, we'll be doing two deployment demos for Hyperledger Besu, and we'll be using the two set of samples that we provide for the platform, which you can find under the root directory platforms folder, and under which you have the various DLT platforms that we support. And under Hyperledger Besu, you have the chart section where you have all the charts, the Helm charts that we have that are required for the deployment, and then we have provided two set of sample values, as we kind of were discussing about the proxy and the vault, and then the various options of having no proxy and no vault. So these are the two set of sample values that we have provided. Um, So we'll first do a deployment of Besu network with 4 validators and 1 peer, and then we can also look into how to kind of have those peers or basically nodes in a different organization. And then we'll do the same setup with 4 validators and node with proxy and vault enabled. So the prerequisites for the no proxy and no vault is the Kubernetes cluster. You can choose to run your local Kubernetes, because for no proxy and no vault, the setup is going to work for a single cluster, as the communication between the validators and basically the communication between the nodes will be through the cluster IP and internal to the cluster. And also the secrets and other crypto materials required for the network to run would be stored on the Kubernetes secrets itself. So no external vault would be storing in the first case. And this kind of setup is suitable for quick testing and POC. We won't recommend this for a production setup, because definitely you need some kind of I mean, the purpose of blockchain is to have other organization participate in your network, and that can be only possible if there's a communication happening which is external to your system and to the other organization. Right. So to get started for the no proxy, no vault, you just need a Kubernetes cluster. We will be using the EKS cluster, which is the AWS managed Kubernetes cluster. And to get started, you first need to go to the folder, which is platforms, Hyperledger, Besu, and charts. And under this folder, you'll have the README file, which kind of covers all the steps and all the configurations that are required to quickly bootstrap the network. This also covers both the, I mean, the deployment commands for both the samples. And once I run these commands, I'll show you what these different values are, and also talk about some of the important fields or variables in this YAML files. Um, so the let's start with the prerequisite. So the prerequisite is to first install the dependencies. So as I think we discussed this in the previous sessions as well, is the new Helm charts that we have written is very much self-dependent, as in the different dependencies, which could be the storage class, or which could be around, let's say, using some common scripts, and all those dependencies are installed as part of the chart dependency itself. So for example, if I show you the nodes, and inside that, if you see at the requirement YAML, these dependencies are defined, which refers to other utility charts that are there in our code repository. So for example, this chart is about storage class. So this abstracts the creation of storage class for various Kubernetes providers. So various providers will have their different storage classes. Um, and then, for example, the node can have a dependency of installing a Tessera node, which is used for private transaction management. So for example, if the Tessera is enabled for a particular node, then it will use that dependency and use the chart, which is the Tessera Besu Tessera node, and install Tessera along with the node. And also, in case it requires some kind of TLS certificate for the SSL communication between the nodes. It uses the TLS cert generation chart that is also provided here in the repo. To create your custom chart, you can kind of disable this and have your own implementation, or maybe modify this to have your own implementation of the TLS certificates. Right. Coming back to the README and running the commands. So I'm gonna install the dependencies. I'll do one by one. So the first one I'm doing is for the Besu Genesis, and then I'll do the node one. So the Besu Genesis chart is responsible for creating the, as the name suggests, the Genesis file for the network, and also it kind of is creates the crypto materials, that is the node key and the other associated things along with it for a particular for basically for the initial set of validators. So for any QBFT or IBFT network, the minimum set of validators required are 4 validators. So by default, we have defined the Genesis to create the Genesis file with those 4 set of validators and their node keys and associated node addresses and then other crypto materials. So I've just done the dependency now, and now I'm gonna run the Besu Genesis chart. And before I do that, let me quickly show you what the Genesis YAML or the sample value looks like. So this is the no proxy, no vault Genesis file, and this will have first will have, I mean, most of these value will have a global section, which is kind of common across all the charts. So the global section talks about the first is the service account that is going to be attached with the each of the pods. And then the vault. So for this setup, since it's no proxy, no vault, the vault type is Kubernetes, which is the it's going to save the crypto materials in the Kubernetes secrets. And then the cluster details, which is AWS as the provider. There you can, I mean, we have tested and have enabled support for Azure, GCP, and also Minikube. Um, so you can have your provider based on whichever wherever you are deploying. And then the cloud native services fall, since we are not using any other cloud provided vault services. This is something which would be kind of working on currently, and then this kind of enables the support for things like AKV, which is Azure Key Vault, or for in case of AWS, the AWS Secret Manager. So in those cases, we will have those options enabled. The other option in the Genesis file is the Genesis configuration. So it has the chain ID, the consensus mechanism that gonna use, and then the gas limit and other various details. The part which I was discussing about the initial set of validators that are going to be part of the network, that is defined through here. So the total number of nodes or the set or the basically the node keys that we are going to generate, the count is 4 here mentioned. You can choose to increase this as your requirement. And so yeah, that's the important values in this file. And then I'm going back to the README here. So just to kind of talk about the command here. So the command is simple. We're going to do helm install, the name of the helm deployment that will come up, the chart name, the namespace in which we are going to deploy, I mean, have the Genesis job deployed. And then it says create namespace. If the namespace does not exist, it will create that namespace. And so that's the command. And before I run the command, I'm going to just show you how the cluster looks like now. So I'm using Kubernetes Lens to show the various deployments that are currently running on the cluster. So if you check the namespace, these are namespace belong to the default services that run for the Kubernetes cluster. The ambassador and the vault are something that we'll talk about when we talk about the proxy and vault setup one. But yeah, these are the ambassador is the proxy and the vault is the vault that we'll be using. And yeah, you see that it's clean. There's nothing here. So let's now run the command. Yep, so it got deployed, and if you look at the things that are happening on the Kubernetes cluster, you see that the namespace got created and the Genesis job is running now. So once that get completed, I can show you the the different Yeah, it succeeded now. I guess I can show you. So in the secrets, you'll see that it has created the keys related to the four initial set of validators that we intended to have. And these are the various details for each of these validators. So it has account addresses, the account key store, account password, the private key, the node addresses, all basically derived from the node key itself. But yeah, these are the different set of crypto materials that would be required for each of these validators. So same for the other ones. You'll see that all of them have been generated now. So this becomes very useful. Sometimes, I mean, you can maybe choose to edit this as well when let's say if you have some node keys for a particular validator already present, you don't want to recreate those keys. So you can have these set of secrets already in place, and then you can just maybe choose to run the rest of the commands, which would kind of use those keys that are already present. So now you actually do the network validator deployment. So this uses the validator.yaml values, and just to kind of show you what this has is the same the global section with the details, and then the storage size and other details for that particular validator. Since this is validator, I mean, there's tesserize disabled for it. And then the other configurations related to the node itself, like the CPU limit, the resources, the matrices, if you want to enable. So those things can be defined here. Also, the whether it's a boot node or not. So those kind of configurations are there, and also the version of Besu and the repo from which this particular version has been picked. So that information is given here. So you can have your own private registry and then provide the basically the tag for it. But then in that case, you need to create the reg cred for the cluster to kind of be able to pull your image from your registry. But then if it is a public registry, you don't have to have those reg creds created for your cluster. But then yeah, this is how you can specify your own repository for your Besu image. Right, so going back to the README, so I'm gonna deploy the validator one by one. So the first validator is so you have to be careful here. So the names here has to match with what we have given, because it kind of matches with the Kubernetes secrets that got created. So yeah, you cannot change the names here. I mean, typically you can change, but then does not matter. I mean, you have to do a bit of tweaking in the code, but then yeah, I guess this is fine. So validator one is deployed. So I'm gonna deploy the second validator. So I'm using the same values, just changing the validator name. Sorry, the Helm deployment name. So which kind of uses the basically the release name to differentiate and then do specific stuff. Right, so I'm gonna deploy the last validator here, and then we'll have a look at the lens. But meanwhile, do we have any questions? Okay. So Shaunak, you have answered this. Yes.
Yeah,
So
so for the recording, yeah, there was a question that if this sample example or the demo is for private Besu network, and yeah, the answer is yes, it is. It is for a private Besu network that you have set up yourself. Yeah, or some organization is setting up themselves. Yes.
yep. Right. So now that the validators are deployed, let's have a look at the uh, pods. Yep. So as you see that, now let me just go by the this one. Yeah. So these are the validator nodes that are running. If you look at the logs, I guess it takes some time to sync, but then it's able to kind of uh, find the other peers, and then eventually once all the validators are synced, and so then it will start blocking or creating the blocks. Um, so yep. So meanwhile this happens, let's go back to the README and then look at the next steps. So now that we have all the four validators up and running, though they have not started creating the blocks yet, but then we can still kind of spin up a member node. I mean, this is basically the non-validator node. And then the value that it is going to use, or the sample value, is the transaction node one. So this one is the value, and then the global section remains as it is. The storage also, I mean, as it is compared to the validator. And then the change is basically here, which is the whether you want to enable the private transaction manager or not. So, I mean, we can demonstrate with the Tessera enabled as true. But then it's up to you and how the network use case is, whether you need a private transaction manager to be present in the network or not. If not, then just disable this. And then rest of the things, I guess, is evident from the names here. These are related to the node configurations, the CPU limit, and stuff like that. Um, yep. So I'm not, so we are not, here you don't see the values that overrides um, the image of, or basically the version of the Besu node that you're running, but then you can safely use this particular um, values here and use it, because if you see that both kind of uses the same chart. So the Besu node chart is being used here. So you can just maybe have the image section here written, but then if you don't define it, that is also fine, because in our charts by default, I guess we have defined the uh, image version and the chart and the repository from which it is being pulled. So I guess if I go node values, yeah. So somewhere at the bottom or top, I would guess there was the uh, yeah, here if you see the Besu repository and tag is provided. So yeah, I mean you can or choose to override those default values and have your own tag or the image basically. Right. So let's run the member node now, or the transaction node. So I'm gonna enable Tessera as well for this. Yeah. So coming back to the validator logs here, meanwhile the member deploys. So if you see, this one is already kind of importing the blocks here. So that means it has started proposing blocks and creating them, and then these are basically importing these blocks. Um, and as you see in the screen, the member is now just starting, so it's in pending state, but yeah, gradually it will just start and then start running. Right. For the next step here, so this talks about the setting up a member or a transaction node in a different namespace. So usually this this is a step where we have differentiated it in terms of a different organization. So this different organization has been kind of separated through the namespace. In case of multi-cluster deployment, this can be in a different cluster also. But yeah, for this one, no proxy, no Vault one, the whole setup is in a single cluster mode only. And then the additional steps that you need to do for deploying in a different namespace is to copy the Genesis file and the static nodes file to the Genesis chart files folder, and then basically run the secondary Genesis chart with the basically run the Genesis chart itself, but then with the secondary Genesis value. Because the Genesis is already created, so you don't want to recreate the Genesis, but just use the Genesis that is being provided from the actual network, which was created, actual Genesis that was created, and also the static nodes, because we are for the um, node discovery, we are using the static node way of discovering the other nodes, which basically the static JSON file will have the node values of all the other validators and the member node that was deployed. In a real case scenario, the Genesis file would be kind of provided by the network operator, or who is basically has started the network. They will have that file, and then you just get that Genesis file, and then also the static JSON file with basically the addresses of the existing nodes. So I'm gonna copy that. So I'm going to that particular folder and then running the kubectl command to create the um, to get the static node JSON file first, and then the Genesis file as well.
So point to note on this one is these two steps is that if you are actually doing a production network and joining some other existing Besu network, private Besu network, these files will be supposed to be supplied by the whoever is the owner or maintainer of that network. Yeah.
Yep.
And in this example, we are running it ourselves, so we can get it directly using a kubectl command. But in a more production scenario, you will not be able to, because you will not be having access to this kubectl or the Kubernetes cluster of someone else, right? So you will getting the files directly.
Yep. Now that the files are here, so this looks like a typical Genesis file for the Besu network, and then the static nodes file with the node addresses for each of the validators, and the yeah, I guess also the member node which was deployed previously. So I'll just now can run the secondary Genesis with the secondary Genesis sample file. Just checking the, yep.
Yeah, and what a secondary Genesis actually just does is that it will not run the whole Genesis, try to run the Genesis again. It will just create the Genesis config maps or the files from the files that we have provided. Yeah, that's the only difference. We call it secondary Genesis because it didn't have to call something else. Yeah, it's not
Yep.
something that it is doing actually running a Genesis again. It is more like just updating the files or saving the files into the Kubernetes cluster. Yeah.
Yep. Right, and then I'm gonna run the other node as well, the non-validator node for the carrier Besu namespace, the new namespace that we're using, and then we can have a look at the lens. I'm going to check if this is fine. So the transaction secondary values. Yeah, I guess this should be fine. Yep. So for the new namespace, if you see, carrier Besu was the one which we created. So the Genesis was succeeded, and then the member is still running, I guess. So it's still in the pre-install stage. So yeah, now you see that the member node and the tester node is coming up. So I guess that's it for the no proxy, no vault setup. Any questions, anyone, before we move to the other part where we show you how the same deployment can be done, but with proxy and vault? Okay, no questions. Then I'll just clean this up. So the cleanup commands are given here below. You should follow this in sequence, or else it might create some issues. So this one just uninstalls the validators that are running. Another important thing is that by default, I think we are not cleaning up the PVCs when we run the uninstall command. So I mean, if you just want to shut down or maybe update your deployments and all, then you can choose to do this. The storage, the PVCs or persistent volumes will still be there. So I'm gonna remove the member as well. And the Genesis. This is taking time. Yep. And now the other member from the different namespace. Right. So now I think, yeah, these are terminating. Um so the as I was talking about the persistent volumes, or basically the storages, you'll see that the data for these nodes are still present. And then for the next demo, I just want to clean them up and do it completely from scratch. So I'm gonna remove the namespace as well for our full cleanup. So Right. So now that everything is cleaned up, we'll move to the same deployment, but now with Proxy and Vault, and then the yeah, with Proxy and Vault. From here, you can um, run these commands. The prerequisite now increases, as in along with the cluster, you now need a proxy service running and also a vault running. So for now, we support the Ambassador edge stack as the proxy service, and then HashiCorp Vault as the vault. We are working on other cloud native vaults, and then hopefully in the next release, we'll have the AWS Secret Manager support enabled. But yeah, for now you need HashiCorp Vault to be installed and the Ambassador proxy. So if you can use the Ambassador documentation to install the edge stack service, but then if you want to use um, the commands, or basically the scripts that we have provided, then you can have a look at the shared folder, and in the README, sorry, in the charts README, you'll have the commands that would allow you to deploy the Ambassador edge stack. The first command is basically to get the dataware repo added. So this is where you have your Ambassador Helm charts provided. This is the official Ambassador Helm charts, and then you apply a custom basically custom the CRDs, which is the custom resource definitions for the edge stack. So this is also taken from the official edge stack documentation itself, but then we have provided the AES CRD files in our repo itself, so you can just you run this command here. Also, next is the actual Ambassador deployment, which we are creating a separate namespace for that, which is a good practice to have your various different services in their respective or different namespace. And then you run the Helm installation command from the official repository of its stack here, and then the version that you provide, and the AES custom values. So this is something which we have provided based on the default values for our network. So I'll just show you how these values look like. It's here in the roles setup, and then it's stack templates, and then AES custom values. So all of these steps were previously kind of part of the Ansible automation. So if you kind of choose to not do all this and then use our Ansible, then you don't have to do all these steps. That I mean, we'll not covering the Ansible part here, but then these steps are also not that difficult. It's just simple commands, and then the values are quite simple to understand. Sorry, I pressed back button here. Okay. So the important part here is the ports, which would kind of create the underlying load balancer service. And then as I was just kind of so for this to work, you need definitely cloud provided Kubernetes, or if you are not having a cloud provided Kubernetes, if you have your own prem or like self-managed Kubernetes, then you have to do some additional steps to kind of set up this proxy service. But then if you're using a managed service, these things become quite easy. So the service type is load balancer, which is going to create the underlying load balancer in the cloud, and then it will enable the various ports that has been mentioned here. So in our case, we are opening the ports from uh, 15010 range to 15050 range. You don't need all those ports. It kind of depends on the number of nodes that you're running, but then I guess 10 or 20 ports are fine for, let's say, six or seven nodes, node network. Rest of the things are kind of the versions and all, which depends on what kind of ambassador or proxy, basically what ambassador you're running, which version of the edge stack you're running. So once your ambassador is set up, you can see something like this is just check the Kubernetes services. So you have this one, which is the ambassador edge stack running with all the mentioned ports in the values file from 15010 range to 15050. And then you also have the external IP or external URL provided by the by AWS here. In case of Azure or I think GCP, you'll have a IP given. And now, once your edge stack is ready, next prerequisite is the HashiCorp vault. You can use the HashiCorp. You can have a look at the HashiCorp documentation. There are various ways of setting up the vault. The way which we are doing it for the demo is using vault on the Kubernetes cluster itself. So this is where in the initial when I showed you the cluster. Sorry, worker loads pods. Yeah. So you see the Vault service running here. So this is running on the cluster itself. So we have used the official Helm charts of HashiCorp Vault. And once we have installed it, we have also enabled the UI for it. So I can just quickly show you the Vault UI and also talk about some of the prerequisites inside the Vault that is required. So let me just grab the URL. So browser here. Yeah, it's open already. So the port was 2001. So I guess it will ask for the root token again. Yeah. So I mean, when you create the vault for the first time, it will kind of do the initialization step where you provide some threshold limits or basically the number of keys to unlock it, or in vault's term it is called as unsealing it. So the prerequisite is to have a vault which is unsealed. So I've already done the initialization and I've already unsealed it, so that's why it's just directly asking me for the root token. So the root token for this temporary vault, I have kept it just a second. uh, yeah, yeah, that's the right. So now you have the Vault UI here. The other prerequisite to have a secret engine enabled. So you can just click here, enable the secret engine. The type of that secret engine is key vault, which is KV, and then do a next, and then have the name of the secret engine. So I'm just going to put secrets V2. V2 is basically the version here. I mean, you can choose to keep any name, but I mean, we have default. I mean, our default values uses this name, so we're just using this name. But it's up to you what you want to have the name as. So it now has the secret. Let me check the spell. Yeah, this is fine. So now the secret engine is running. With the name secrets V2. So both the prerequisites are done. So Vault is running and unsealed and has a KV secret engine running. The Ambassador load balancer is the Ambassador edge stack is running with the load balancer created, and um, now we'll look at the values and how it changes from the previous no proxy, no vault setup. So yeah, from here, I guess, right. So the here, as you see here, it's written in that first we have to change the global vault address and then also the global cluster Kubernetes URL and also provide the proxy external URL suffix. So vault as address, I mean, it's simple. You have to just add the vault endpoint, which is here. Let me show you an example because the first chart we're going to run is the Genesis one. I'm going to show you on the Genesis here. So the vault type changes to HashiCorp Vault. It was Kubernetes in the previous case. Now the network is, yeah, of course, Besu. And then the address is the vault address that we just saw that because we are creating it as a load balancer service for the vault and running in the cluster, it is like this. And then the auth path, which is basically the authentication way or the access thing for Vault. So this is how I mean, you can choose to keep anything you want, but for our case, we have kept it supply chain. This will be a name that will be used for the auth. And then the secret engine, this should match with what you have created in the Vault UI, or basically you can create it through Vault command as well, but basically this should be the secret engine that is running. And then the secret prefix is where the various secrets would be kept. So Vault saves the secrets or values in a very path-based directory way. So this is where under this path, the other secrets or all the secrets that are needed would be created. And in the vault role name that is given, this is also specific to the authentication or access of how the cluster is going to basically communicate or authorize itself with the vault. The other details is going to be the same, just that the Kubernetes URL would change. So this is also used for the vault to basically authenticate the cluster. So that's where it uses needs the vault, sorry, the cluster URL. And then rest of the things remains as it is. So for Genesis, you don't need the other requirement which was written here as in the external URL suffix. When I deploy the node, I'll show you that one. But then for Genesis, this is fine. So I'm just gonna run the commands. The additional step here is also to kind of create a secret which would have the vault root token. So this is just a one-time process because the cluster or the basically the pods needs to communicate with the vault, and then that initial set of authentication needs to be done. So for that case, we initially need the root token to create that kind of the initial authentication. After that, the root token is no more used. It all works through the role binding, and then the I think the path-based authentication and the access thing will work. I'll show you that how it works, but yeah, this is just a once-time process. Creating the namespace so that I can create the secret which holds the root token. Okay, so the root token is created. I can now run the Genesis uh, job, which is going to do the same thing, create the Genesis file for the network, and then the initial set of node keys for the four validators. Okay, so this is done. Now I'm gonna deploy the validators. The changes that you see here is the additional value that we are passing in the command line, which is the proxy P2P port. So this is the port that is used for the P2P communication between the nodes. So if you remember when we were talking about the proxy and the ambassador, its stack and the various default values, so there we mentioned that we have opened port from 15.0.10 range to 15.0.50. So this is why we had opened those ports, because we're going to use this here for the P2P port for each of these validators. So, I mean, based on the number of validators and number of members you have, you can choose to enable those ports specifically. But yeah, for our case, we have just expanded it to test out a large number of nodes, basically. And yeah, I'm gonna run this, but then let me show you the validator YAML file here. So everything remains as it was in the previous Genesis file. Just the additional thing is the external URL suffix. So this is the, as the name suggests, is the URL suffix for that particular um, what particular deployment. So in our case, all the validators are going to use the same suffix with their name as in yeah, with their name as the prefix. So this is the domain which we own, and this has to be mapped with the edge stack or the proxy load balancer. Yeah, you can choose any kind of mapping or based on wherever you have bought the domain. So yeah, that mapping has to be there for the network to work. Now, I'm gonna run this. Yeah, let me just reconfirm if I have all the values correctly written. Yeah, I guess this should be fine. Yeah. So deploying the second validator, changing just the P2P port. So the P2P port here is the communication between the validators, the which uses, I think, the RLPX protocol. The RPC is protocol. The RPC for that particular node is still going to happen over HTTP port 80. So that's why we are not explicitly mentioning it here, but then we are also enabling RPC endpoints for these validators so that you can do some kind of maybe admin related stuff, or basically use the RPC to deploy contracts and stuff like that. Okay, and then I guess the third validator and then the final validator. Okay, let's look at the lens now. Yeah, so all the validators are up and running, though it's just started 100 seconds ago. Let's see if they have started creating the blocks or not. So it's still not synced with all the validators. But the important things which I mean should look into is, I guess, the uh, hold on. Yeah, is the static JSON file, which will show you that, or maybe I can show it here itself. Uh, config map that creates the static JSON file, I guess. Yeah. Yeah, not this one. Group nodes. Yeah, let me just download the file. It will be better, I guess. So, yeah. Or maybe just, yeah, the Besu peers one is holding the static nodes. Yep, got it. So right, if you see the enode addresses for each of the validators, you'll see that now instead of using the internal the service name, the pod name, or basically the service name and the namespace as the URL, it is using the external URL suffix that we provided prefixed with the name of the deployment or the name of the release, and then the ports that we provided. So though these are running in the same cluster, the communication is happening through the proxy using the domain names that we provided. Right, and then I'm gonna not do further deployment of the member node. Um, uh, yeah, but because the process is going to remain the same. And just maybe show you that the other RPC endpoints that got created. So you can see it in the mapping, which is basically the definition, custom resource definition for edge stack. So edge stack creates the mapping. So if you check the mapping, you'll see that the other the RPC endpoints of the validators or the nodes that we deployed. So this uses the validator one RPC dot the suffix that we provided, and then yeah, there's no port defined because it's using the port 80 HTTP or HTTPS here. And then yeah, it redirects to the internal service or the internal RPC endpoint of the validator in this case. So I guess that's it from the demo. Any question, anyone? I've been talking for long. I don't know whether I'm still online or not. Any response from anyone?
No, you are online,
Okay. Okay.
Suvajit. Yeah, I don't think there is any question.
Okay.
So did you show like running that endpoint with this?
Uh, as in through the
Yeah,
uh,
like doing the REST API call. I think there is a test, right?
yeah, I can probably do that. Yeah, let's do that. Do you have the curl command here? Yeah,
Yeah.
I guess. So let's do this.
Yeah, so this is like to test that your endpoints are working fine. And generally, for a public network in the sense where your things are updated, I think you have to give HTTP.
Yep.
Yeah. Then it is accessible. But if it is only internal, like without proxy, then it is not going to work because it will be internal to your Kubernetes. Mm.
Yep. So, excuse me. So we have enabled the it API for the nodes that we deployed. The you can look into the various configurations for the nodes here in the chart itself. So if you go to chart templates and then Besu config, you'll see the various configurations that we have used. You can choose to disable some of these APIs. For example, you can choose to enable the RPC. And I guess somewhere we have also mentioned the various, I think it was in the values where we mentioned the various APIs that are supported. So yeah, the eth API was also there. So just gonna run the command now. Something didn't work. Okay. So curl data is an RPC method. This. Okay. Something strange. You see.
So it
Let's see if
just
the
responds empty. I think the
yeah.
blocks are not getting created in that
Okay, let
case.
me check. No, blocks are
Okay.
getting created.
Okay. I mean,
Maybe some.
anyways, yeah, some other
Yeah.
network issue, I guess. Have we get, but this is your personal machine or Accenture?
E No, this is So I'm running it from the Accenture machine.
Maybe it's getting blocked there.
Mm,
Uh,
could be, yeah. But
okay. So there is a question, how much does it cost to host these validators nodes on AWS? So I mean, this is depends. So we are not hosting any validator or nodes or Besu nodes in this example directly, right? We are deploying the nodes, Besu nodes and or validators on our EKS cluster on AWS. So the cost will be whatever is the cost of an EKS cluster. Generally, it's like depending on the machine sizes that you choose when deploying, when and the number of machines, you will there will be different cost on for EKS. So that will be the cost. We are not deploying independent EC2 nodes here from here. That's what we never do it. This application is or the Besu network is deployed on cluster on Kubernetes cluster for any environment, AWS, GCP, Azure, Minikube, anything. Yeah. Yeah, that's all then. Anything? I don't think there is any more question.
I'm gonna give it the last try on Postman. Let's see.
Mhm.
I have the Besu uh, API, sorry, Besu collections there. So if it just allows me without signing in. Oh, I guess it will not. Uh, yeah, I'll leave it then. Okay, back to the deck then. Let's see if I alt tab it here. Okay. So, you guys are able to see my the presentation, right?
No, it's screen, your VS Code.
Okay,
Yeah,
let me reshare then.
I think that one will work if you choose that.
This one?
Yeah, yeah.
No, I
No,
guess
it's
it's in
not.
the,
Yeah.
yeah, it's on the screen too. So let's let
Oh,
me
okay.
reshare. Mm, Yep, I guess it's up now.
Yeah.
Okay, so future releases and I think we spoke about this in the previous sessions as well. But yeah, in kind of bullet points, these are the various features that we are looking towards. Some of these we have started working on, some we are looking for people who are interested in and then want them to come and help us and have these supports enabled on our on the Bevel platform. So support for Corda 5 is definitely up in our roadmap. I think now Corda, I think they have come up with a stable Corda 5 version. So yeah, if someone is interested, they can come and join our calls, and then we can discuss and have and kind of plan to have Corda 5. The other thing is the so we have now that we have standalone Helm charts, and then these Helm charts are now being kind of pushed to the GitHub repositories in the GitHub Helm repo itself. So in the Ansible way of deployment, the GitOps sources can directly use the Helm repositories. So it would be kind of make it kind of independent of the source chart itself. So it can just use the charts that we have published. The other thing that we were currently working on is the support for cloud native vaults, and I think I was talking about the AWS Secret Manager, which is being worked upon. So this, I mean, with the new code design, I mean, it kind of easily allows you to add this support. So we'll be demonstrating how it can be done for AWS Secret Manager, and then maybe if someone is interested and if they are working on Azure, they can add the support for the Azure Key Vault, which is going to be kind of similar. So you have to just write the abstraction functions, which would or the basically the API functions, which will allow to read and write to the respective vaults. The other thing that we are kind of actively looking towards is the Fabric 3. I think this is still in beta release. So once they come up with a stable release, we'll do some kind of exploration, and then definitely would require help from you guys to add support for Fabric 3 as well. The other important thing that we found and saw in our I think a year back we integrated the HLF operator, which was called the HLF operator that time, which uses the Kubernetes operator pattern to deploy Hyperledger Fabric. So we added it to our Bevel umbrella, and then it is now called as Bevel Fabric operator Fabric. And so we plan to have similar, since we saw that there are a lot of people who are interested in having Kubernetes operator using for deploying these platforms. We wanted to plan out adding other platforms and using the Kubernetes operator to automate or basically orchestrate the deployment. So this is also something in roadmap, but it all kind of depends on the various interest levels that we see from the community, and based on that, we'll have them as a part of, or basically groom them into issues and start working, or maybe have contributions from you guys. Shaunak, you want to add anything on this?
No, that was a very good summary. From updates from our side is, yeah, we are having other discussions on some maintainers, additional maintainers. So yeah, if you guys are interested to become a maintainer, you can ping us directly, or I mean on Discord, and then also or join the channel, the mailing list and all, and email from there as well. And yeah, that will be welcome. Otherwise, from from me and Suvajit, from our this presenter side, I think we are from our side will be retiring by end of this this year, basically, from Bevel maintainers.
Yep. So right, so this is why this becomes important. So Shaunak has already invited you, and again, this is your invitation to come and help us maintain the project. And in a way, I mean, you can come and actually shape the direction in which the product is going. You can tweak it or tailor it as per as your need. You're free to do, as long as it kind of is in line with the vision of what the product is supposed to do. So yeah, again, please do join and help us in maintaining this product. Right. So the various repos that we have under Bevel is the Hyperledger Bevel primary repo, the demo, the repository which we're using for the demo. It kind of has all the platform Helm charts. So we currently support 7 platforms: Hyperledger Besu, Hyperledger Fabric, Hyperledger Indie, Quorum, R3 Corda open source, and R3 Corda enterprise, Substrate. I think I covered all the 7. Yeah. So these are the various DLT platforms that we support, and all the Helm charts, standalone Helm charts for this are provided in this repository. We have another repository which is the Bevel samples. So initially, when we open sourced, we had 2 reference applications that we had provided to kind of test your DLT networks. So these application sample applications were based on supply chain use case and an identity use case. The identity use case primarily uses the Akapai one, the Iris example. So that's primarily for Indie, and then the supply chain use case works for all the DLT other DLT platforms. And then the another repository which I was just previously talking about, the Bevel operator fabric that we I think last year we integrated it. So it uses the Kubernetes operator pattern to do the network orchestration. So yeah, these are the repos. So if you are interested in any of these, you can come and help us on any of these repos or all of them. So I guess right. So all our community calls happen on open Zoom calls. So we have frequent workshop series. Your this one is one of those series, and we also have bi-weekly sprint planning calls, and then roadmap grooming calls, and also the PI or release demos. So yeah, I mean, do feel to drop in any of these and join and help us again in driving this product. So I guess that's it. Thank you so much. If you guys have question, please feel free to ask. There's no question on the on here Zoom in the Zoom link.
No,
Is there?
there isn't. I don't see any question on the YouTube. Yeah.
Okay.
So yeah, it's all right. Thanks everyone. Thanks for your time and joining. And yeah, hopefully we have answered some of the questions. And the YouTube recording will always be there in case you want to share with your peers and friends, and yeah, or refer it later. That's all. That's all from us. Thank you, and have a nice evening or afternoon.
Thanks everyone. Thank you,
Thanks,
Sownak.
everyone.
Thank you.